This is lesson 5.7, Use Partial Quotients with a Remainder. It is found on pages 241 through 244 in your workbooks. So I was in downtown Moore a couple of days ago. Saw these two guys walk into a bar. Yeah, two guys walked into a bar. Fortunately, the third one ducked. Yeah. Y'all thought I was talking about that other place, didn't you? This is school. Don't talk about that in school. Moving along. So our learning target for this lesson is to use partial quotients to divide with a remainder, and of course, by the end, you want to be at a number 3 so you can do it on your own. And of course, if you don't understand it yet, well, that's the whole point of being in school, right? If you haven't learned this yet, well, that's why you're here. All right? So let's do some looking back. We're going to use an area model to find 240 divided by 15. Well, if I think of 15 times 10, it would be 150, right? And 15 times 2 would be 30, so 15 times 20 would be 300. That would be too much. So I'm going to put 10 in here. All right, so I've got 10, and that makes this 150 because it's 10 by 15, so 150, 10 by 15. Well, what do I have left when I subtract 150 from 240? I have 90 left. Well, I know I can put 6 in. 6 times 15 is 90. Trust me, it is. So we're going to put 90 in here. Well, if we do 10 plus 6, that's going to be 16. All right, so our look ahead kind of tells you about the limitations of an area model. Can you use an area model to find 190 divided by 15? Explain why or why not. Use a drawing to support your answer. Well, here's what that's going to look like. So if we have 150 here, we're going to have 30 here. That's 180, right? Well, we got a remainder. We have a remainder of 10. Well, you can't have a remainder of 10 in an area, right? It wouldn't show it. So here's what we're going to say. Well, first of all, let's put our answer, 12 remainder 10, and here's what we're going to say. No, you cannot draw an area model that shows a remainder. So then, can't use that model. What model can we use? Well, we can use partial quotients to divide, and that's our key concept for this lesson. So our example, find the quotient 890 divided by 52. So they show it like this, right? We do it a little different because instead of divide by 52 equals 10, we do times 10 equals 520, right? But it's the same thing. We invert to show multiplication, right? And they do it here. They check with multiplication, right? The 10s and the 1s. Well, all right. Let's see how they do it here. So 520 divided by 52 equals 10. 364 divided by 52 equals 7, right? And they get 17 remainder 6. So, you know, if we did it this way, we would have to know that 364 divided by 52 equals 7. Well, how do we do that? Well, the first thing we do, we start multiplying, right? We start thinking about our multiplication. So that's how we're going to show it. But that's how they are finding it, because they do the partial quotient of 10, divide 520 by 52 to get 10, and then divide 364 by 52 to get 7. They add the partial quotients, which is what we're going to do too, to get 17 remainder 6. That's what their remainder is, right? And remember, you always continue to divide until the remainder is less than the divisor. Alright, so I'm going to do 1 through 3 with you because the way they do it on number 1 and 2 can be kind of confusing because they don't show you their thinking, and their thinking has to do with multiplication. They just show the division. Alright, so I'm going to show their thinking over here so that you can see how they got their numbers. Because honestly, I'm wondering, where did they get 410 from? Well, when we think about it, when we think about 41 going into 523, well, can I put 10 groups of 41 into 523? Well, yeah, that's going to be 410. That's where they got the 410 from. Well, why did they get 10 instead of 20? Well, remember, 20 times 40 would be 800, right? 2 times 4, 2 zeros, right? That would be 800. That would be way too much, right? Because 20 times 41 would be 820. Well, I know that if 20 times 40 is too much, I know for sure that 20 times 41 is too much, because 41 is bigger than 40, right? See how I use my estimation and my powers of 10? So, right, if I did 10 times 41, I would have 410. That's where they get that. So we're going to put 10 here. All right, and then we're going to subtract. 3 minus 0 is 3, 2 minus 1 is 1, 5 minus 4 is 1, so 113. Well, if I do 2 times 40, it's going to be 80, right? So 2 times 41 is going to be 82. That's how they get their 82. If I did 3 times 40, 3 times 40 would be 120. Mr. Premier, why do you keep saying 40 instead of 41? Because 4 is an easier number to work with. We got that math fact, right? Look, 2 times 40, 80. 3 times 40, 120. 2 times 4 is 8, 10. 3 times 4 is 12, 10. So I'm using a number that's close to 41 that I can work with easily. All right? See, this is where our powers of 10 and our estimation skills come in handy. That's why we did those skills before this, so that we can use them now. So 2 times 41, 82. So I'm going to put my 2 here. I'm going to subtract 82 from 113. So we got 1, and then 11 minus 8 is 3. So we've got 12 with a remainder of 31. How do I know I'm done? How do I know I'm done? Well, we're doing whole numbers now. We're not thinking about fractions or decimals yet. We're doing whole numbers, and I can't take a whole group of 41 from 31. I can't take a whole group. I can take part of a group. Absolutely. You can be a fraction or a decimal, but I can't take a whole group, because 31 is less than 41. Now I can stop. So we've got 12, remainder 31, because my remainder of 31 is smaller than my divisor of 41. Now I can stop. So we can see now, can't we, that long division, being the calculator in long division, requires that you use a lot of your skills. All right, let's go on to number 2. All right, so in number 2, they are doing something a little different than what I would do. Here's what they're doing. So they're thinking, well, if I do 10 times 87, that's going to be 870. I can't put any 10s in there. So I can't put any hundreds, I can't put any 10s. How many 1s can I put in there? What they're thinking is, well, what if I just take half a 10 and do 5? What if I just do 5? So they do 5 times 87 to get 435, right? Now, you know, I want you to show your work. So I would have you do 5 times 7 is 35. 5 times 8 is 40. 40 plus 3 is 43. So 435. That's how they get that. And of course, you know, like I said, being the calculator takes a lot of work when it comes to long division. So they're going to subtract and get 5. Oh, let me borrow. That's 5. 5 minus 3 is 2. 7 minus 4 is 3. So 325. Well, then they need to subtract. But wait, Mr. Penguin, how did they get 261? Well, they did 3 times 87. How I would think of this is I've got 8 here, and I multiply it by 3, to get 24, which is close to 26. So they did 87 times 3, and if I did that right here real quick, 87 times 3, 3 times 7 is 21. Carry my 2, 3 times 8 is 24, 24 plus 2 is 26, 261. That's how they got that. So let me erase that. So they got 3 times 87. So they got 8, and then when they subtract, they got 4. 12 minus 6 is 6, so 64. 64 is my remainder. Why? Because it's less than the divisor. It's a big number, but it's still less than the divisor. So we're going to have 8 remainder 64. Right? Now, I would do this different. Here's how I would do it. Mr. Paymer, you do it different. Does that mean they're wrong? Nope. They just used different numbers. Here's what I would do. I would think 8 and 76. 8 and 76. Well, 8 times 9 is 72. And I could try that. Or I could even try this. I would do this in my estimation. I would make 87 90 because I would be rounding it up. 87 is closer to 90 than 80, so I'd do 90. Well, then I would think, okay, I've got my 9 here, right? How many times can 9 go into 76 before it goes over? 8 times 9 is 72. 9 times 9 is 81. That'd be too much, so I'm going to do 8. 8 times 9, see? Make that 720. 720 divided by 90 is 8. 8, right? Because 72 divided by 9 is 8. 10 minus 10 is no zeros, right? So I'm going to take 87, multiply it by 8. 8 times 7 is 56. 8 times 8 is 64. 64 plus 5 is 69. 69. So 696. Did you know what? Check it out. If I subtract 760, or not 760, if I subtract 696 from 760, 696, I got 4, because that's going to be 10, that's going to be 15, that's going to be 6. 15 minus 9 is 6, 64. So it would be 8, the remainder 64 still. Right? So that's how I would do it. But you know what? This is how they did it. They used 5 and 3 on their partial quotients and added it to 8. You can do that. I like doing it this way. I'll show you in number 3. So we've got 846 divided by 93, and they conveniently put it over here for you, so thank them for that. The first thing I'm going to do is an estimation. I'm going to round 93 to 90 because it rounds down to 90. It's closer to 90 than it is to 100. So I'm going to think, what is a number that 9 can divide into, because I'm just using my one digit, that's close to 84. Well, that's going to be 81, isn't it? 9 times 9 is 81. So 9 times 9 is 81, 10, right? So I'm going to use 9 as my first digit here. So I'm going to do 93 times 9. Well, what is that going to be? Well, let's do 93 times 9. 9 times 3 is 27. 9 times 9 is 81. 81 plus 2 is 83. So 837. That's pretty close, isn't it? That is really close. So we've got 837. Need to do some borrowing from there. 16 minus 7 is 9. 3 minus 3 is 0. 8 minus 8 is 0. So our remainder here of 9 is smaller than our divisor of 93, so we can stop. So what is our quotient? 9. We can't put any more groups in. So we got 9, remainder 9. Yeah, there's a lot to do. We're going to estimate first to get our first digit. We're going to try our first digit, because sometimes our estimation number here is either too high or too low, right? It may be that 9 times 93 was more than 846. In this instance, it wasn't. So our estimation gave us a good number. So we may have to do less than 9. We may have had to have done 8, but in this instance, we could do 9. You see that? It gets us close. It gets us close to the digit that we need. And sometimes, and in most cases actually, it gives us the first digit. Yeah, a lot of work that you have to do. A lot of work that you have to do. And I'll take you through this when you do number 4 on your own. But for now, let's stop there for the day, and then we can start on number 4 tomorrow. This is day 2 of lesson 5.7, Use Partial Quotients with a Remainder. It's still found on pages 241 through 244 in your workbook. Today we'll start on page 242. Anyone know what one nut said to the other nut that he was chasing? Yeah, one nut chasing another nut. What did he say to him? I'm a cashew. I'm a cashew. Catch you. Moving along. Alright, number 4. First thing I want you to do is do the estimation. Do the estimation and then we'll go over it. Alright, so my estimation is going to be 30 and 600, right? 3 and 6. That's going to be 20. Well, can I use that first digit? Can I use that first digit? I can try. I can do 31 times 20. Yes, that's 2. Oh, that's too much. What do I need to do then? Well, use the next digit down. Use the next digit down as 10. Alright, so let's use 10. 10 times 31. Now notice I've got an opposite here. On number 3 I did 31. Well, I didn't do 31. I did 93. But remember, in our commutative property, you can do it either way. So 10 times 31, let me erase this over here. 10 times 31 is going to be 310, right? I want you to go ahead and finish that out. Finish this out, and then we will go over it. Alright, so we got 310. That's 5. 10 minus 1 is 9. Oh, need a bar there. And 5 minus 3 is 2. 295. So, look. 31, 29, they're really close to each other. They're really close to each other. What digit am I going to try? I'm going to try 9. Just because they're really close to each other. So, 31 times 9. 9 times 1 is 9. 9 times 3 is 27. 279. Think of that 2 better. 279. 15 minus 9 is 6. 8 minus 7 is 1. So I can do my 9. So 9 times 31 equals 279. So 19. 19, what is my remainder going to be? 16. 19, remainder 16. Again, yeah, it takes a lot of skills to do all this. Alright? I want you to try number 5 all on your own. Try number 5 all on your own, and then we'll go over it. And you know what? Before we go over it, you can try any of the methods that you want on this. Any method that you want trying to solve this. And then we'll go over it. Well, alright. I'm thinking that 10 times 47 is going to be 470. 2 times 50 would be 100. So 20 times 50 would be 1,000. That'd be too much, right? So that's where I see. So I did 50 and 1,000. But if I did 50 and 1,000 times 20, well, 1,000 would be too much to take away from 846, right? So I used my 10, so 470. Got 6, 14, 7. 14 minus 7 is 7. 7 minus 4 is 3. Well, if I do estimation of 50 and 400, 50 and 400, well, 5 can go into 48 times. I'm going to try 8. So I'm going to try 8 times 47, and 8 times 47. 8 times 7 is 56. 8 times 4 is 32. 32 plus 5 is 37. Check it out. So we've got 18. What's my remainder? 0. 0. So again, estimation skills, power of 10 skills, multiplication skills. My goodness, we're using all these skills when we're the calculator. Alright, yep, or 0. Okay, number 6. Number 6, do that one all on your own, and then we will go over it. Alright, so I'm thinking 28 times 10, because if I do 30 and 450, well, 3 can go into 45 15 times. So I'm going to use 10 or 1 as my first digit there. Right, so I've got 280. Well, let's subtract 280. Get 6. 17 minus 8 is 9. 3 minus 2 is 1. 196. Well, if I did 30 to 180, I would have 6, not 60, I would have 6. Let's do that. Let's do 28 times 6. 28 times 6, we're going to have 6 times 8 is 48. 6 times 2 is 14. 6 times 2 is 6 times 2 is 12. 12 plus 4 is 168. 168. I think that's too little. Right? I'm going to try it over here just real quick. 1996. I think I can put one more 28 in there. So that's going to be 8, 16. 16 minus 8 is 8. 8 minus 6. Oh, I could put exactly one more. So let's erase this and put 7 in there. And that's going to equal, I've already seen it, 196. So 196, and that's going to be 17. 17, remainder 0. Do you see how I did that there? I did my estimation. I saw that it was too small, so I just did one digit larger, not 3 or 4, not more than that, just one digit larger, and I got the exact digit I needed. Right? So remember, estimation puts you close to the number you need. It doesn't always give you the exact number, and you can just go back and see if you can do another digit that's very close to the digit that you got with estimation. Alright, so again, we have to use a lot of skills with division, with long division. You know what? I know it's hard. Life is hard. So is math. Oh my goodness. Did you just say that? Yes, I did. Moving along to number 7. Remember, we have it where it's 65 into 305. All right? Go ahead and try that, and then we will go over it. Alrighty, so in my estimation, I'm doing 70 and 28 because 7 and 28 are math facts. So I'm going to do 65 times 4. 4 times 5 is 20. 4 times 6 is 24. 24 plus 2 is 26. Alright, well, if I did it one more time, it'd be 325. So 260 is 65 times 4. Let me erase this part. Alright, so we got 5, 45 left. So we got 4, remainder 45. And it's going to be 72 divided into 7,336. Go ahead and try that, and then we'll go over it. Alright, so place value is very important here, because if I do 70 into 7,000, well, I can do 7 divided by 7 is 1. How many zeros? 3 zeros minus 1 zero is 2 zeros. So I'm going to multiply it by 100. So 100 times 72 is going to be 7,200. So let's put 7,200 in here. 6, 3, and 1. Well, I'm going to say it's just once because twice would be 140. 2 times 70 would be 140. That would be too much, so I'm just going to do 1. So 1 times 72 would be 72. 6 minus 2 is 4. 13 minus 7 is 6. So 64. So 101. 101. Remainder 64. Let me put that here. 101. Remainder 64. Alright. One more. Let's try one more like this one, and then we'll go over it. So on this one, I'm going to try the big 7. So 49, 1,335. Well, I'm going to do 10 first, because 10 is 490. Got 5, 13, 12, 845. Well, I can do 10 more. 5, 5, and 3. Well, I can't do 10. 8 times 50 is 400. I'm going to do 7. 49 times 7. See how I did that? See, I know that 7 times 50 is 350. So 7 times 49 should be close to that. 7 times 9 is 63. 7 times 4 is 28. 28 plus 6 is 34. So 343. We're going to have 12 left over. So we've got 27, remainder 12. 27, remainder 12. Alright, so let's go on to some other practice. We're going to use multiplication to check whether the quotient is correct. So in other words, on this one, I would do 32 times 22. I would get the answer and then add 3. I want you to go ahead and do that, and then we'll go over it. Alright, 2 times 2 is 4. 2 times 3 is 6. Drop my 0. 2 times 2 is 4. 2 times 3 is 6. So I have 4, 10, 704. 704 plus 3 is 707. So that's correct. Alright. Go ahead and do this one. Go ahead and do number 11, and then we'll go over it. Alright, so we need to do 43 times 19. 9 times 3 is 27. Carry that 2. 9 times 4 is 36. 36 plus 2 is 38. Gonna drop my 0 because I'm in that tens place. 0. Make it look more like a 0 instead of 6. 1 times 3 is 3. 1 times 4 is 4. So I've got 7, 11, and then 8. And then we've got to add that remainder 1. And it's going to be 818. So that one is going to be incorrect. All right. Number 12 wants us to complete the pattern, and let me tell you, it's a lot easier than you think. Right? Because look, 22 times 24 is 528, right? So 22 times 24, 528. We got a remainder 3. What are we adding? 3 to it. So 531, right? So I'm going to add 6. See, because it's all divided by 24 equals 22. And we're just adding the remainder to 528. So 6 plus 528 is 534. Go ahead and fill in the next 6, and then we'll go over it. All right, so we got 529, 532, 535, 530, 533, and 536. All right, so yeah, we were just adding the remainder. Let's go ahead and make this a 3-day lesson. We'll stop there and start on number 13 tomorrow. This is day 3 of lesson 5.7, use partial quotients with a remainder. It is still found on pages 241 through 244 in your workbooks. Today we'll start on page 243. So, I got an email from Google Earth a couple of days ago, and it said, here at Google Earth we can spell maps backwards. I thought to myself, that's just spam. Let me know when you get it. Or if you don't want to get it, you just want to move on, then let's move on. Alright, on this next one, we're going to circle the division problems that have a non-zero remainder. Now, if we do some thinking about this, we don't have to really solve the whole division problem to know if it's going to have a non-zero remainder, right? It's wanting to know, is this going to have a remainder, right? Well, look, this has a 5 at the end. 845 has a 5 at the end. Well, I know that anything that's going to be divided by 20 needs to have at least a 0 at the end. There's going to be at least 5 remaining. So this is going to have a remainder. All right. When we have 25, again, this 5 tells us, well, the ending number needs to at least have a 5 or a 0, right? 25 tells us, because we have 25, 50, 75, 100. They have it either a 0 or a 5 at the end. That does not have a 0 or 5 at the end, so we know that's going to be having a remainder. All right? So with 50, we know that the numbers either end in 2 zeros or end in 50. Well, that's going to not have any remainder. Okay? And if we look at 30, we can think about the powers of 10. 10 times 30 is 300. 20 times 30 is 600. 30 times 30 is 900. Well, we know that that's going to have a remainder then. All right? So we just have to think about the ending numbers and what these numbers are. All right? Just have to do some thinking about those, and we don't have to do all of the long division. All right. Number 14, we've done something like this before when it comes to divisibility rule. I want you to read over number 14. This can be one of those jaw your answer moments. All right. So read over number 14. It says use the divisibility rules. Circle the division problems that have a remainder of 0. All right. Go ahead and do that. Then we'll go over it. All right, did you get these? Get those 5? Yep. It's those 5. 2, the number is even. None of these. Well, that one's not even. This one's even. Okay. The sum of the digits is divisible by 3. 4 plus 5 is 9 plus 8 is 17. Not divisible by 3. 4 plus 5 is 9. 9 plus 3 is 12. Divisible by 3. And then the 5, the 1's digit is 0 or 5. See, that's not. That is. Number 6, the number is even and divisible by 3. Well, that's even, but 8 plus 9 is 17. 17 plus 6 is 23. That's not, and that's not even, and that's not even. And in the 9, the sum of the digits is divisible by 9. And, oh, that was 6, not 9. So 2 plus 9 is 11. 11 plus 7 is 18. 2 plus 8 is 10. 10 plus 9 is 19, so that wouldn't have been it. And then the 1's digit is 0 if it's divisible by 10. That is 0. This one is not. Well, alrighty. Let's connect this to data. In our example, you want to plant all the flower and vegetable seeds. You want to put 1 seed in each section of a 12-section egg carton. How many egg cartons do you need? Well, it says flower and vegetable seeds, right? Flower and vegetable seeds. So they add 119 plus 95 and they get 214. And then they divide 214 by 12 and don't show their work, knuckleheads. But we're going to trust them that it's 17 remainder 10. Are you really going to trust them, Mr. Penguin? 10 times 12 is 120. 7 times 12 is 84. That's going to be 204. Remainder 10. They're going to have remainder 10. So yeah, because that's 10. That's 7. So okay. Trust but verify, right? Well, they have 17 remainder 10. Well, what are you going to do with those 10 seeds left over? You're going to put them in another carton. So they need 18 egg cartons. So yeah, you got to think about what you're going to do with that remainder in a word problem. Well, all right. Why don't you go ahead and read and solve number 15, and then we'll go over it. A screen printing shop makes 425 yellow t-shirts and 311 blue t-shirts. A shipping box can hold 28 t-shirts. How many boxes are needed to ship all the t-shirts? So we need 425 plus 311. That's 736 total t-shirts. Each one can hold 28. Alrighty, so I'm thinking 2 because 2 times 30 is 60. So let's do 2. And 2 times 28. Oh, that's going to be 56. I know that. So 560. Got 6, 13, 7, 176. Well, 10 can't fit in there. 5 times 30 is 150. I'm going to try 5. 28 times 5 is 40. 5 times 2 is 10. 10 plus 4 is 14. 140, that would be 36 left. So there'd be more than that. So I'm going to multiply it by 6 then. Let me make some space for myself over here. 28 times 6. 6 times 8 is 48. 6 times 2 is 12. 12 plus 4 is 16. So 168. 168. So 16. We're going to have 8 left over. So 26 remainder 8. How many boxes am I going to need? No, not 26 remainder 8. There's no such thing as a remainder 8 box, right? What am I going to do with those 8 t-shirts that are left over? I'm going to put them in another box. Now, is that box going to be full? No, it's just going to have 8 t-shirts in it. So I'm going to need 27 boxes. Yeah, let's figure out what we're going to do with that remainder. We're not just doing math. We are doing math to solve the problem. But let's make sure we're answering the problem. Okay? Well, all right. Number 16. Go ahead and resolve that one, and then we'll go over it. All right, so 968. See how many groups of 32 we can get out of it. Well, I'm going to say 30 here, because I know that 3 times 3 is 9, and 3 times 2 is 6. So that's going to be 960. Oh, that's going to be easy. 30 remainder 8, right? Well, what is the remainder 8? That's the ounces I have left over. Oh, it wants to know how many 32-ounce bags of popcorn can I fill completely. So I can only fill 30 bags completely. I'll have just 8 ounces left over. All right, number 17. Number 17 I'm going to help you out with because it can be a little complicated. So it says you need 24 strawberries, 28 grapes, 16 raspberries, and 6 blackberries to make one fruit bouquet. How many of the bouquets can you make with the fruit shown in the table? Right, so we got 934 strawberries. How many do we need for each bouquet? 24. So 934 divided by 24. All right, and then how many grapes? 28. So 985 divided by 28. And then raspberries, 992. We've got 16. Okay, and then blackberries, we need 6. Right, so doing all these division problems. 4 big O division problems. So do each of those 4. Yes, it's going to take us some time. Do each of those 4 problems, and then we will go over it. All right, so 934 divided by 24. Well, if it was 20 and 800, it'd be 4. 24 times 4, that's going to be 96. That's going to be too much. So I'm going to do 24 times 3. That's going to be 720. So we get 4, 1, 2. I can't do 9. How about 8? Oh, I can't do 10. How about 9? That'd be 180. Let's try that. Maybe it's too much. 24 times 9. Oh, I know it's going to be too much. 36. 9 times 2 is 18. 18 plus 3 is 20. Oh, wait, 216. That's too much, yeah. So I know it's going to be 8. 24 times 8. So we get 8 times 4 is 32. 8 times 2 is 16. 16 plus 3 is 19. So 194. 192, so the goose. 192. So 4 minus 2 is 2. 11 minus 9 is 2. So we got 38. 38 remainder 22. All right, so we're just going to say 38 though, because we can't make another bouquet with that one. So 38. Hope you understood that part. We can't make another bouquet with those remaining strawberries. We can make 38 bouquets. All right, so 985 divided by 28. So 28 into 985. Well, if I did 30 and 900, we'd be 3. Well, let's try that. 28 times 3. 3 times 8 is 24. 3 times 2 is 6. 6 plus 2 is 8. So, got 3 here. 840. So we got 5, 4, and 1. 7 times 30 would, I'm thinking 20. I need to think 30. So 5 would be 150. And that's really close. So I'm going to do 28 times 5. 5 times 8 is 40. 5 times 2 is 10. 10 plus 4 is 14. 140. So we got 5, right? So 35, remainder 5. Now remember, we're not going to do anything with that remainder 5. We can only make 35 bouquets out of 985 grapes. All right, let's go to the raspberries. So the raspberries, we have 992 divided by 16. So if I did 20 and 100, that'd be 5. Let's do 5. What about 6? Let's try 6. That may be too much. 36. Oh no, it's wonderful. So we got 60. That's going to be 960. And 2 and 3. Oh, it's going to be a nice round number because I know that 32, not 22. So that's going to be 62, right? And let's go to the blackberries. So 956 divided by 6. Well, I know that can be 100 into 900. 106 is because that's 600. So we got 6, 5, 3, 35. Well, 6 times 6 is 36, so let's do 5. 5 times 6 is 30, and we got 56. Well, we've got 9 times 6 is 54, remainder 2, so that's 159. Alright, so we've got all these numbers. How many of the bouquets can you make with the fruit shown in the table? Think about this. I've got 35 grapes. I want about 35 grapes, but I can only make 35 bouquets with the number of grapes that we have. And because I can only have 35 bouquets of grapes, well, there's not going to be enough grapes to make more than 35 bouquets, even though we have 38, 62, 159 here. We can only make 35 bouquets. Oh my goodness, that took a lot of work. This lesson took a lot of work, didn't it? With all the skills that we had to use, right? In our learning target, if we go back to it, use partial quotients to divide with a remainder, right? Hopefully you can do that. You can use partial quotients to divide, and you can find a remainder. And of course, if you're in number 2, it's okay. I love you. We can work on this together. I will gladly give you help. And if you're in number 4, you can help those peeps who are at a number 2. Well, all right. Have a good one.